Good morning, my YouTube viewers. In this video, what we're going to talk about is tax returns and fraudulent tax returns, to be in fact. And we're going to be using the binomial distribution to answer some questions about tax returns. So the practice question is, the IRS estimates that 5% of many high net worth tax returns are fraudulent. These tax returns will contain errors that are purposely made to cheat the government. Although these errors are well concealed, suppose that an IRS audit will uncover them. If 100 tax returns are audited, what is the probability that 5 fraudulent tax returns will be uncovered? So what we're going to do is we're going to write a program in Python to answer this question. And before we write the program in Python, what we need to do is we need to import the library that we're going to use. So from scipy.stats, we're going to import binomial. So scipy is Python's scientific library, and stats is a statistical module within scipy. And binomial is the distribution that we're going to make to solve this problem. So we're going to set up the parameters for the binomial distribution. N is the total number of tax returns, and that's 100. P is the probability of a tax return being fraudulent, that's 5%. And the number of successes we're interested in is 5. So we're going to calculate the probability of exactly K fraudulent returns. Probability equals binomial.pmf, that's probability mass function, brackets K equals 5, comma, N equals 100, comma, P equals 0.5. And then we're going to print the probability of uncovering exactly K fraudulent tax returns out of N audited is approximately the probability. So the answer to that is the probability is 18%. To have 5 fraudulent tax returns out of 100 using a binomial distribution, it's 18%. So the next question we have with regard to tax returns is, if 250 tax returns are audited, what is the probability that the IRS will uncover at least 15 fraudulent returns? And this is the survival function. So we're going to set up the parameters. So N is the number of trials or number of tax returns, that's 250. P is the probability of a single tax return being fraudulent, that's 5%. And K is the number of successes or the number of fraudulent tax returns being 15. So we're going to calculate the survival function is probability at least 15 equals 1 minus binomial.cdf, and that's cumulative distribution function, brackets K equals 15, comma, N equals 250, comma, P equals 5%. And the probability, and then you're going to print the probability that the IRS will uncover at least 15 fraudulent tax returns is approximately 18.87%. So now the next question that we have is exactly the same as the other one, except that we're using SF instead of 1 minus binomial.cdf. So So we just want to see, because it's supposed to be the same, but I just want to prove that it's the same. So again, you got 1/88. So basically, you can either use 1 minus binom.cdf or binom.sf, and that will give you the same value. And it's just two ways that you can do it. And as I've said in earlier emails, earlier videos, that if you're using Excel, I don't think Excel has a survival function. So you'd have to use the 1 minus binom.cdf. So the next question we have is, if the 250 tax returns are audited, what is the probability that the IRS will uncover at least 15, but at most 20 fraudulent returns? And so we're going to import the library scipy from scipy.stats, import binom, and we're going to set up the parameters of the binomial distribution. So N is the number of tax returns audited, being 250. Probability is the probability of a single tax return being fraudulent is 5%. So K1 is 20 and K2 is 15. So we're going to calculate the cumulative probabilities. Probability at most 20 equals binom.cdf brackets K1 equals 20, comma, N equals 250, comma, P equals 0.05 brackets. And then the probability of less than 15 equals binom.cdf brackets K2 minus 1 equals 14, comma, N equals 250, comma, P equals 0.05. And then we're going to calculate the probability for 15 is less than or equal to X is less than or equal to 20. So probability between 15 and 20 equals probability at most 20 minus probability less than 15. So we're going to print the probability that the IRS will uncover at least 15, but at most 20 tax returns is approximately a probability between 15 and 20. So the answer that we have is 25.63% to answer that question. So the next question we have is, what is the probability that out of 250 tax returns, no fraudulent returns are uncovered? So we're going to import scipy. So from scipy.stats, we're going to import binom. And then we're going to set up our parameters. N is the total of tax returns audited, being 250. P is the probability of a single tax return being fraudulent, 0.05. And the number of fraudulent tax returns uncovered is 0. So we're going to calculate the probability of uncovering exactly 0 fraudulent tax returns. So probability no fraud equals binom.pmf brackets K equals 0, comma, N equals 250, comma, P equals 0.05. And then we're going to print the probability that no fraudulent tax returns are uncovered out of N audited is approximately probability no fraud. And so the answer to that is 0%. There's 0% probability that they're not going to get any fraudulent tax returns. So that concludes this video. The next video, we're going to be talking about light bulbs, and I hope that you decide to watch it.